Uh, very good morning, good afternoon, good evening to all the participants and the students, and welcome to this course titled Multi-Criteria Decision Making. And as you know, this is an NPTEL MOOC course which is spread over 12 weeks with 60 lectures, and each week we have 5 lectures and each lecture being for half an hour. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, the broader set of points which we are discussing, and I keep mentioning them, which is multi-criteria decision making. Under that you have two main topics. One is multi-objective, which we have discussed in details, solved quadratic programming, linear programming, both integer programming, for the bi-objective case, for the multi-objective case, in the sense when there are 3 objective functions, dealt in the techniques, showed the graphs, the results, the Pareto optimality frontier. Then we discussed multi-attribute in details. We did discuss about attribute theory or utility theory, then multi-attribute, even though they were the only main points were mentioned. And based on the multi-attribute, we started the different type of qualitative multi-criteria decision making. And the main one which we had just started was the TOPSIS method. And if you remember, for this set of classes which are related to multi-attribute theory or this non-parametric decision making, the details will be solved in the Excel sheet, and I will share the Excel sheet accordingly. And whatever I will share only one Excel sheet, it will be kept, I will keep updating it and inform you accordingly, and obviously the slides are all available with you. So, this is the 41st lecture out of the 60 lectures for this whole course. So, it is the continuation of the TOPSIS method, which is technique for order preference by similarity to ideal solutions. Now, if you remember, we did mention that there was one matrix which was basically mentioned as X, and in that X, if I go to the Excel sheet which was here, if you see the first sheet of the Excel sheet, and this Excel sheet main file has been saved as MCDM. The first sheet which we were discussing was the TOPSIS method. Now, when I mentioned about X, and I also mentioned about the weights and also R, so I will just recapitulate. So, you have 4 alternatives. Each alternative is based on 5 criteria, and the column wise values which you see, and why I am repeating it, if it is a repetition, please excuse me, because this type of concept will be utilized for all the other methods also. So, the values which are highlighted in column C, which is for the first column C1, criteria 1, the corresponding value corresponding to the first criteria accruing to A1 to A4, alternatives 1 to 4 are 10, 5, 15, 20. Similarly, corresponding to the second criteria, the weights are given as highlighted 25, 15, 25, 30. Then we come to the third criteria, values are 25, 35, 40, 30. Then it is the fourth criteria, which is C4, 30, 40, 45, 35, and finally, you have the fifth criteria. Again, those values corresponding to A1 to A4, which are the alternatives, are the values are 15, 10, 10, 5. Now, once this is done, we need to normalize, and I told you normalization can be done in different ways. So, the normalization which is there and which I will try to highlight using this PPT file, it will be easier for me to highlight, and obviously, once you see the videos you will understand that. So, considering normalization, first I will use different colors to highlight the concepts of normalization. So, we will normalize according to how the rows and the columns have been represented. For our example, we are taking the alternatives along the rows and the columns are the criteria. So, based on that, if I follow, One normalization can be considering the values each cell is xij. So, when I consider xij, which are the cells for the total matrix X, capital X. So, this will correspond to I is equal to 1 to capital M, where capital M is the number of alternatives, j is equal to 1 to capital N, where capital N is the number of criteria. So, column row wise, column wise. So, the normalization can be done based on xij divided by the sum of xij. Now, if you see, I have not put any limits whether we are trying to calculate column wise or row wise for the xij's. That will, again I am repeating, based on the fact that how you have placed the rows and columns corresponding to alternatives and criteria. So, with this, if I go back to the Excel sheet, so here it is, the first value. So, the normalization which I just showed, which is xi divided by the sum of xij's, I am not going to use it now, I will do it within few minutes, which I have already done. So, this cell value is basically based on the idea that it is xij whole square divided by the sum of the square values, such that the sum would always, when you normalize, the sum would be 1. So, if I follow that, the corresponding xij's when converted into normalized values are for criteria C1 are given as this, which is 0.13. I will only treat till the second place of decimal, 0.13, 0.03, 0.30, 0.53, and the sum is 1. Similarly, if I consider the same concepts of normalization corresponding to C2 criteria, C3 criteria, C4 criteria, C5 criteria, the values are given as here. For C2, if you see, again only reading till the second place of decimal, 0.26, 0.09, 0.26, 0.37. Then again for C3 values are given 0.14, 0.28, 0.36, 0.20. For C4 there are 0.15, 0.27, 0.35, 0.21, and last is C5 is 0.50, 0.22, 0.22, 0.05, and check the values are 1 as highlighted in the yellow rows. Hence, it is mentioned as sum. Now, in place of the normalization which we did, which was like this. So, normalization which we did, I will use a different color. It is xij whole square divided by xij's whole square and summed up along the column. So, this is the blue one is the normalization which we used. Similarly, you can use the normalization shown as in the first part, which is in darkish red. Other different normalization technique can be used. You can use the logarithmic normalizations. So, now the idea is, the question would immediately come is that why are we using this normalization accordingly? Because if you remember, we have considered different type of utility functions. Some were quadratic, linear, logarithmic, exponential. So, based on the idea how the overall utility accrues to the decision maker based on different criteria for each alternatives, we will use the normalization based on that concept of utility function. So, once I come back to the Excel sheet, so based on x, first I get the normalized matrix, then the weights are there, and the weights, if you remember I mentioned, they are the importance you are going to place on the each criteria, nothing to do with the alternatives. So, once you multiply, so technically the weights are as shown. So, I will just highlight it with, say for example, light blue. So, the weights which are given is 10%, 20%, 10%, 30%, 30%. So, if you add up is 3, 4, 5, 6, 7, 8, 9, 10, which is basically 1. So, the weights add up to 1. So, I am giving 10% to C1, 20% to C2, 10% to C3, 30% to C4 and 30% to C5. Importance. When I use weight, which is given here W multiplied by R, and obviously you should remember the row and column size of R and W. Based on that, I have the values given as y here. Now would come the main part. Now, by the way, here for the time being I am considering, if you remember in the TOPSIS method, a word was mentioned about most ideal and the least ideal solution, PIS and NIS. So, now based on the PIS and NIS concept we will proceed, but few important points I will keep mentioning as we proceed. Now, if the decision maker decides on the set of the weights which I just mentioned, the weights are given from by W1 to Wn, and n, if you remember, is the number of criteria as I mentioned. Sum of the weights is 1 as mentioned in this first bullet point. So, the weights are given here W and the sum is 1. Now, consider the weights for this problem given as, I will keep flipping from that Excel sheet to here. The weights are given as 0.1, 0.2, 0.1, 0.15, 0.25, 0.3, and based on that I find out y, which is x shown here, multiply R and W. Now, as I said, how do we rank? These values which I find out based on the multiplicative factors of R and W which we got is basically, I will highlight this one is the weight, I am marking in red, and this is basically R, normalized matrix corresponding to x. Based on that, the values which I get is V matrix, and the V matrix values are here. I highlight that in green. So, if I go back to the Excel sheet, the R matrix normalized multiplied with the weights is W, I get V, which is y given as the cell values, and remember I have highlighted the cell values with red color. So, they will keep changing depending on the normalized concept which I am taking. Now, we will calculate the values of the most positive ideal solution and then corresponding to that the most negative ideal solution. Now, if you consider, what we will do is that for each value, that means considering I is equal to 1 to m is, remember, the number of alternatives which you have, we will find out that corresponding for each and every values which we have. So, as I changes to 1 to m, which is here in this case, let us verify, here in this case m is 4 and n is 5. So, corresponding to finding the values, I find out for each I is equal to 1 to m, what is the max value. So, if I consider I is equal to 1 here, and I will come to the negative solutions also, for I is equal to 1 to m each value. So, I will do it. I find out y plus. Similarly, I will find out y minus also. What is my y minus? I will come to that. So, here, so I is equal to 1. So, this is the first one. I will write, even though I am writing it below, it is basically maximum. So, this is for the first one. Similarly, so okay. So, I will utilize the fact I is equal to 1, then y plus I is equal to 2, I do it max of the second, which is A2, then I do it for the third. So, I am just copying it. So, I do it for 3, and finally, I do it for 4, and this is the fourth value. So, all the max values have been calculated. Similarly, so I will just highlight it as required with some color. So, let it be light green here. So, zoom in for better visibility. So, obviously, I will share this, you will understand. So, and now I find out for minimum. So, this would be y I minus y minus, but here rather than max it will be min. So, if I calculate its min of I is equal to 1 to m. Similarly, I copy it and I will change it accordingly. What do I change? I change here I 2, I 3, I 4. So, these are the max and min values, and they are, let me highlight, this is basically used for PIS and this will be used for NIS. Why PIS, why NIS? Let us go back to the Excel sheet. Now, here, so we need to find out V plus, which is y, the values which I have calculated. This is, as mentioned, is the most positive ideal solution. So, the values V 1 to V n would basically depend on the values as calculated. So, just 1 minute. I should have. So, basically my maximization would be different here, just 1 minute, because there the rows and columns were different. So, technically it will be I is equal to. So, if I have interchanged the rows and columns, they would be accordingly calculated. So, I will do it here again for this case. So, it will be max of, if it was basically interchanged. So, it will be maximum here, then maximum found out for second values, maximum found out for the third value, maximum found for the fourth value, and finally, maximum found for the, just 1 minute, fifth value. So, similarly, if I have the NIS based on interchange of the rows and columns, I would find out the minimum for the first value as I am going. So, I do it for the second, I do it for the third, I will do it for the fourth, and finally, I do it for the fifth. Now, with this I proceed. So, once I find out the max and the minimum. So, this is the maximum found out for each I is equal to 1 to m. Then I have calculated the negative, that is the more negative solution, which is the minimum. So, maximum minimum we have found out. Now, given the maximum minimum, I want to calculate the corresponding distance from the best solution and the worst solution. So, when I am talking about the best solution, the worst solution is like this. The maximum of any set of values, technically I would find it or consider it as the best, and the minimum I will basically technically find it as the worst. For each of these V matrix values, V matrix values if you remember is the multiplication of the normalized values with their corresponding weights. So, I need to find out like this. This is consider the line, this is the best solution, and this black spot is basically the Vij's, and this the blue one is the best. Similarly, I have the worst also, because that is the max and min. So, I need to find out the distance. I will use the blue color. I need to find out the distance here, and I need to find out the distance here. So, this blue one I will mention as V plus, this is V minus, and the distance function which we find out or utilize is basically a simple Cartesian L2 distance. Now, the question would come, depending on your requirement of whether you want to use the L1 norm, L2 norm or L3 norm or L max norm, the distance formula will change and distance value which you find out would also change. So, that would basically give you a weightage concepts. Weightage why? Because if you remember I had mentioned, so consider the distance as, even though it is written as S plus, consider S plus we are using. So, this will be S plus from the positive, this is the S minus from the negative for all these different criteria alternatives, and based on that I want to find out what is the overall ratios of the normalized weights. Why? Consider theoretically, if this Vij is here, which means it is furthest from the negative one. So, obviously, it is good that it exactly matches the positive value given, such as the weights or the overall criteria importance I want to give, or the collective criteria importance I want to give for the Vij's would be the maximum. In case if Vij is on the red dot, which is the most negative solution, then obviously in that case it is furthest away from the blue one, most ideal one. In that case, the so called weightages or the importance I want to give to that particular alternative would be the least. So, based on the maximum and the minimum, or the highest value and the lowest value, we will rank them. And again, the distance measures can change. So, we calculated S plus based on the most positive ideal solution given on L2, which is squared norm. Then we calculate S I minus based on the most negative solution, again it is based on the L2 squared norm, and I find it for each individually for m is equal to 1, 2, 3, 4, find out their maximum minimum value. And then one is found out is here, and this what I was talking about, I can again draw the diagram. So, if I have the real line, sorry for the repetition, plus please, this is the best solution PIS, this is the worst solution NIS, Vij is here, I find out which is here already found out Si plus. I find out this which is Si minus, and based on that I try to find out and calculateCij's, which will give me the ratios. The ratios are depending on what is the negative worth and the positive worth. Now, the question would immediately arise, can't we use Si plus in the numerator and do the calculation? Yes, we can do the calculation. So, that will give me a overall ranking based on the ratios of the best solution and ratios of the worst solution. Now, the question would be, what would be the best and what would be the worst solution? Consider that, if you remember, one of the examples which you have considered was Mr. Murthy buying a house in the city of Vizag. So, in that case, price, more the price is worse off, or say for example, maintenance cost being high, definitely not required. Safety being good, that is a good point. Schools, colleges being in a very nearby location is good. So, we will basically consider all those positive points based on which we will find out the best distance or the PIS or the most ideal solution, and based on the fact which are negative, which do not give any positive value, we will basically club them and find out the NIS point, and based on that we will do the calculation. Even though as shown here, we are only highlighting one point, but that can be expanded depending on how you have been able to divide the positive and the negative one. Now, if we come back to this Excel sheet, I did not mention anything about the criteria. C1 to C5 were considered as they are, but in case if you want to put importance on C1 to C5, consider C1, C2, C3 are positive and C4, C5 was negative, then obviously your PIS would be based on C1, C2, C3, and similarly the negative solution will be based on C4 and C5. That means, we will basically differentiate the criteria and the importance and their effect, positive and negative, in two sets, and find out the PIS based on the positive set and find out the NIS based on the negative sets. So, consider the problem is related to buying the house apartment among 4 choices, where the decision to buy the house or an apartment are based on 11 different parameters. 4 choices means 4 locations, 4 alternatives, and the criteria parameters are 11 in number. So, they are, consider city, price, loan availability, location, number of rooms, safety, proximity to market, proximity to school, proximity to hospitals, facilities available, resale condition. Now, if the question is that how do we differentiate the positive and the negative one? So, let me highlight it. Consider here, if it is price, higher the price is definitely not guaranteed, it is not required or we do not want. So, we will highlight it as the one which will fall in the category or the subset of negative points. If I consider loan availability conditions of the loan are very stringent, then obviously it becomes a negative set or a set for the negative points. Now, in this case, in these two red one which are highlighted, if higher the prices, higher the conditions for the loan availability are, it is negative. That means, more it is increasing, it is having a negative effect. Lower the price, lower the loan availability is good, that means it is manageable. Now, having said that, if I look at the other side of the picture, consider number of rooms, consider safety, consider facilities available. I will only highlight these 3, it can be done for the others. More number of rooms, better. Safety features being better is good, facilities available being higher is good. That means, if you consider the red and the blue one as subsets, higher the values in the blue is positive, higher the values in the red is negative, and vice versa when the values decrease. So, hence, having said, you can easily divide the positive set and the negative set into 2 different classes and do the calculation based on which you can find out the CI plus and the CI minus. I will come to that in the next class. Have a nice day and thank you very much.